Hi friends, today I'll continue the class of GMIN 2014 solutions. So first of all, I'll explain one problem from the integration. The problem is like this. The problem is integration of 1 plus x minus 1 by x e to the power of x plus 1 by x dx. So this is a problem given in GMIN 2014 from the indefinite integrals. Now here actually the main key concept of the problem is sometimes we cannot find out the integration of particular functions. So if it is not possible to find out integration of particular functions, what we will do, we try to cancel that integration which we cannot find. Okay, so that is the technique we are going to use. So in this integration by parts also we are using. Now what I will do, this is equal to integration of, I will multiply with 1 first, 1 into e to the power of x plus 1 by x dx. Here this is the part of the integration, it is very difficult. Actually we cannot find out this integration, okay, in any regular method which we learn, okay. Now what I will do, plus integration of x minus 1 by x, okay, this one x minus 1 by x e to the power of x plus 1 by x dx. Now here this is the part of the integration we are going to simplify this, where in this integration we will get this integration again with the negative symbol which we can cancel, right. So now what I will do, because of e to the power of x plus 1 by x e to the power of x plus 1 by x, this is I am going to take as t. So if I take this as t, what happens? So if I say this is t, what happens? X plus 1 by x, if I say t, its derivative is what? X derivative 1, 1 by x derivative minus 1 by x square dx is equals to dt. Okay, so x plus 1 by x is equal to t. If I say 1 minus 1 by x square dx should be equals to dt, and 1 minus 1 by x square, this is the function we need in this integration, right. So here we have x minus 1 by x, but I want 1 here and 1 by x square here. So what I will do, I will take x common. I'll take x common. So here you will get 1 and here you will get x square. So that we have to do now. Integration of e to the power of x plus 1 by x dx plus integration, what I am doing here, x taking common, what will get 1 minus 1 by x square, this you are going to get. So 1 minus, I am copying here 1 minus 1 by x square, together with that I will write this function e to the power of x plus 1 by x, and whatever you take common, that I am writing here x dx. Okay, now here if you see the substitution method, if you take x plus 1 by x as t, its derivative 1 minus 1 by x square is here. So what I will do, I can find out integration of this part. Okay, I can find out integration of this part. So say for example this function is g and this function is f. Okay, so now first I'll explain what is the integration of g. Okay, so if you want to find out integration of g dx, what is the value of this? So if I say this is t, 1 minus 1 by x square dx is going to be dt. So what is remaining part now? Integration of this will become e power t dt, and e power t dt is what? E power t. So e power t means e to the power of t means x plus 1 by x. So e to the power of x plus 1 by x. So what is integration of g dx? Integration of g dx is e to the power of x plus 1 by x. Okay, now I know integration of g dx, but I have to find out integration of x into this. So I use now integration by parts. Okay, this is I suppose as f and this is I suppose as g, because of I know integration. So formula, using the formula of integration by parts, what is the formula for integration by parts? Integration of f into g dx is equals to f integration g dx minus derivative of f, again integration g dx of, for this integration one more dx. So this is the formula. Integration by parts, we must know this to solve this problem. Integration of f into g dx is equal to f, as it is f will write, then we do integration. Okay, then we will do the derivative of f, then again we will do the integration, whole function once again we integrate that. So this is the integration by parts. Okay, so the first part I am not going to do anything, because of this I am going to be it is going to be cancelled out. Okay, in dx plus, now use the formula, plus f we have, f is x and integration g dx we have. Integration g dx is what I know already. I calculated e to the power of x plus 1 by x. I copy that, e to the power of x plus 1 by x. Then we have formula minus integration of derivative of f. Here we have f is x, derivative of f means derivative of x, derivative of x is 1. So I'll copy that 1 here. 1 into integration g is integration g, but integration g is e to the power of x plus 1 by x dx. Now can you see here, the first integration we have e to the power of x plus 1 by x dx, and the ending term is minus integration e to the power of x plus 1 by x dx. So these two will be cancelled out, and the remaining part is x e to the power of x plus 1 by x. So the result is x e to the power of x plus 1 by x. Okay, so here what we did, the first integration which is not possible to find out, but the second we simplified, and in that, by using integration by parts, that first integration is cancelled out. Okay, so this is the technique. Sometimes whenever some functions given which cannot be for which we cannot find out integration directly, so we simplify the function in which we are going to get the same integration, and we can cancel out. Okay, so this is the technique you have to remember, cancelling the integration sometimes for those functions which cannot be integrable. Okay, now you see one more problem I will take from the calculus. So the problem is, okay, now you see the problem from the definite integral. So it's a problem based on the graph knowledge. You must know the graph of the sin x, where it is positive, where it is negative, and where it has more than 1 by 2 values and the values less than 1 by 2. That is the main key points for this problem to solve. So now you see, first of all, you must know that it's a perfect square. You must observe that it is in the form of perfect square. So this is equals to integration of 0 to pi. Actually this is 2 sin x by 2 minus 2 sin x by 2 minus 1 whole square dx. So in fact what we will do in generally, whenever you have root of x square, we always write x, but this is wrong. Root of x square equal to x is wrong. Root of x square is actually modulus of x, and modulus of x is maybe x and is maybe minus x. This is depend on whether the value inside the modulus is positive or negative. So inside mod positive, as it is we will take x, but if inside mod it is negative, we will write x together with the minus symbol, minus x. So mod x value is minus x if x is negative, mod x value is x if x is positive. So here, after removing this square and root, okay, after cancellation, what you have to write actually, modulus of 2 sin x by 2 minus 1 dx. So this is the result of root of 2 sin x by 2 minus 1 whole square. It's not like square root cancel and 2 sin x by 2 minus 1. That is wrong. Root of x square equals to x is wrong. Root of x square equals to mod x. Now you see, whenever there is a mod for x, so mod x will become x. Mod x would be x if what? X is positive. This value should be positive to write x. So here inside mod it is positive or negative, right? So now you see, first of all, if for example sin x by 2, 2 sin x by 2 minus 1, if you want to say positive, so when it will become positive? When 2 sin x by 2 is more than plus 1. So adding 1 on both sides, or minus 1 taking that side, is more than plus 1. Then sin x by 2 is more than what? Half. So when sine function is more than half, that you must know. Okay, so sine function is more than half, then it will become positive. So when sine is more than half, now in the graph I will show you sine function when it will become more than 1 by 2. Now you see here, this is the graph of sin x. So maximum value of sin x is plus 1 and the minimum value is minus 1. So that's why the graph is in between plus 1 line and minus 1 line. So here what I will do, I will draw a line parallel to x axis at the value 1 by 2. So this is the horizontal line. Okay, at 1 by 2, I draw a line parallel to x axis, y is equals to half. Now you see, the sine graph is above this half line, above the line y is equals to 1 by 2. This is, you can say y is equals to 1 by 2. So the graph, this portion is above the line y is equals to half, means in this region sine value is more than sine theta or sine x. If I say sin x is more than half here. So what is that? What are the values? This value and in between these two values. So this value is what? At 1 by 2, at 1 by 2. Okay. So sin 30 degrees, that is sin pi by 6. So at pi by 6 and this is at 5 pi by 6. So therefore in between pi by 6 to 5 pi by 6, the graph of sin x is more than 1 by 2 in between pi by 6 to 5 pi by 6. So whenever the angle is in between pi by 6 to 5 pi by 6, the sine value will become more than half. But here x, I say the graph of sin x this is, but here we have sin x by 2. So whenever this sin x by 2, this x by 2 angle is in between pi by 6 to 5 pi by 6, then it is more than half. So x by 2 should be in between pi by 6 to 5 pi by 6 to become positive, right? So multiplying with 2, what happens? This 2 will be cancelled into 2 into 2. So therefore the x value between pi by 3 to 5 pi by 3. So whenever x is in between pi by 3 to 5 pi by 3, the function inside the mod will become positive. The function inside the mod will become positive whenever x lies between pi by 3 to 5 pi by 3. But pi by 3 is 60 degrees and 5 pi by 3 is what? 5 pi by 3 is what? 5 into 60. 5 into 60 is 300 degrees. So whenever the x is in between 60 degrees to 300 degrees, the 2 sin x by 2 minus 1 will become positive. But here our x is in between 0 to 180. So we cannot take 60 to 300. So we will take only 60 to 180. So in between 60 to 180, instead of taking pi by 3 to 5 pi by 3, what I take? Pi by 3 is less than x is less than pi. In this region, this 2 sin x by 2 minus 1 will become positive. And other than this, it is negative. Other than this means actually 0 to 180. Actually 0 to 180. But from pi by 3 to pi by 3, it is positive. And 0 to pi by 3, it is negative. So make use of this and split the given integral. So I'll remove this. So using the graph, with the help of graph, I decided the function inside the mod when it is positive. So here you can see. So what I'll do, I'll split this 0 to pi as 0 to pi by 3 and pi by 3 to pi. So this is equals to integration 0 to pi by 3 modulus of 2 sin x by 2 minus 1 dx plus integration, the other interval is pi by 3 to pi modulus of 2 sin x by 2 minus 1 dx. Now you see here in between 0 to pi by 3, what we are saying in between this 0 to pi by, okay, so integration 0 to pi by 3 where it is negative and pi by 3 to pi where it is positive. So what I told, mod x value is x if what? X is positive, otherwise it is minus x. So inside mod if you have x, the same x we are going to write if x is positive. So in this case it is negative. So therefore what I will do, integration 0 to pi by 3, this is what? X, but negative, so minus x. So minus of 2 sin x by 2 minus 1 dx plus in this region pi by 3 to pi, what it is? The function inside the modulus is what? Inside the modulus is positive. So therefore it will be mod x is equals to x if x is positive. So therefore it is as it is itself, modulus value is itself because of it is positive. So 2 sin x by 2 minus 1 dx. So the problem is at most done because of just here what we have to do, simplification and simple integration that is remained. Now see, I am going to integrate this, then I will apply the limits. So this is what? Minus of minus plus 1, integration of 1 dx is a x, okay, and minus 2 sin x by 2 integration, sin x by 2 integration is minus cos x by 2 upon 1 by 2. So this will become minus 2 cos x by 2. So minus of minus plus 2 cos x by 2. Okay, the limits are what? The limits are 0 to pi by 3. Next plus here also 2 sin x by 2. Again like this you are going to get integration minus cos x by 2 by 1 by 2. So here we have 2 minus 4 cos x by 2 minus 1. Integration of 1 is x. So minus x. The limits are what? pi by 3 to pi, right. So this is equals to, first you have to substitute upper limit. So what is that upper limit? Pi by 3 plus 4 cos pi by 3 by 2 pi by 6, then minus of lower limit 0, here it is 0, and cos 0 is how much? 1. So cos 0 is 1, 1 into 4, 4, so minus 4. So this part is over, plus what I will do, I'll take minus common. I'll take minus common. So minus common. So both will become plus. So this is plus now. This is also plus. Substitute first upper limit. What you will get? 4 cos, upper limit is what? X value pi. So cos pi by 2 plus x value is how much? Pi. Minus of, then lower limit, cos pi by 3 by 2. So 4 cos pi by 6 plus pi by 3. Pi by 3. So at most the problem is done. Pi by 3 plus 4 cos pi by 6 value root 3 by 2 minus 4, and taking minus inside, cos pi by 2 value 0. So 4 into 0, this will become 0. So minus pi, and minus of minus plus 4 cos pi by 6 value root 3 by 2 and plus pi by 3. So this is equals to 4 root 3 by 2 plus 4 root 3 by 2, it is 4 root 3. Then I copy this number minus 4, and pi by 3 plus pi by 3, 2 pi by 3 minus pi. So 2 pi by 3 minus pi. How much? 2 pi minus 3 pi, that is minus pi by 3. So 4 root 3 minus 4 minus pi by 3 is the value of the given definite integral. So here just two important things I'll repeat now. Okay. So one important thing is what? Root of x square is what? Mod x, not x. And mod x value is what? X, if x is positive. So if you know the value inside mod is positive, you have to write itself. If the value inside mod, if the function or the value inside mod is negative, what you have to write? X you have to write, but extra minus. So mod x value is minus x if x is negative. This is the important point in this problem. So what we have in the problem? Modulus of 2 sin x by 2 minus 1 dx, some interval 0 to pi we have. So here we have mod. So when it will become positive, when it will become negative, that you have to decide first. So where it is positive, that region you have to do the integration separately, and where it is negative, for that part also you have to do the integration separately. So we have to split the integral according to the positiveness or negativeness, the sign of the function. According to the sign of the function, you have to split the integral. So splitting integrals in the definite integral is the most important concept. So this is this question is framed on the splitting intervals according to the positiveness or negativeness of the modulus function. So modulus function definition is this. Okay. So I will continue GMIN 2014 problems in the next class. Stay tuned to my channel. Thank you for watching my videos.